Okay, welcome back. As promised during the last lecture, I am producing here an additional recording to go a little bit through the coding associated with what we have discussed in the last part of the last lecture, which were the Java methods, so object-oriented methods, and as well as the creation and instantiation of objects. So as you can see from my screen, I left this from where we were during the last lecture. What we had done there is to create a static method allow. And this means that this is a class method, so there is an instance of this method which is for the whole class, and all this method does is to print allow. And we mentioned here in this main function that you could call this, you're allowed to call this method directly with its name just because the main method is included within the class, and therefore we are within the same namespace of the class itself, and we can refer directly to the hello method without using the dot operator. However, if the main method was to be defined outside of the class, we would have had to use this notation here, where we use the name of the class and not of the particular instance of the class, so the particular object of the method's class dot hello. And this is because this is a class method. Then we discussed also about the fact that in Java, essentially all variables are passed by value. And in particular, this has some specific consequences in terms of whether changes to variables are propagated to the original variables or objects. And so one of the examples that we made here was this integer k equals 5, and we printed it out here before any changes. And actually, let me repeat the example here. We were using this method, which is add1, which all it does is to add 1 to an integer and return the resulting value. And we discussed that this is not going to change the value of k. Let me rerun this to show you what is going on. So as we can see, even if the method is supposed to add 1, it's not affecting the value of the integer variable k. And this is because when we are passing our argument to add 1, a copy of k will be made. So the value of k will be copied into this variable, local variable I. The local variable I will be incremented by 1, and then the value of the local variable will be returned. So if we wanted to propagate the change to the caller variable k, the only way we have is to set k equal to the result of that method. And so what that will do is to copy the value which is returned by the method at 1 into k. And so let's run these to see what happens. So as you can see now, the value has been changed, and And so this is showcasing the fact that variables of which are associated with primitive types are passed by value. Now, one additional example that we can make here is to instead use an object. So as I said before, the objects are a little bit different, and all we are doing when we're passing an object to a given method, we are passing by value the reference to that object, where you can think of a reference as the address of that object in memory. And therefore we are making a copy of that reference, but the reference also allows us to access the fields associated with that object, and therefore to propagate the changes to the original copy of the object that we passed to our method. So an example here that I'm going to discuss is that of arrays. So let's say we know that arrays are objects, they are not primitive types. So let's define an integer array. Let's call it a equals new int, and then we can use an initializer list just for the sake of this example. Okay. Now let's say that we would like to write a function that mutates this array, or specific values associated, specific elements of this array. To do this, the first thing to do is to write a function that allows us to do that. So one way to do it is, again, let's write another class function that we are going to call, let's say it's a void function, and we're going to call it mutate array. We are passing our integer array as a parameter, and now we are going to change, let's say the second, well actually the third element of that array, and the value of the third element of that array, and we are going to set it to 8. We're not returning anything, this is a void function. So let's see what are the effects of this mutate array on our array object here. So first, let's print out the original elements of the array. And we have discussed a type inference, so let's use that, and the enhanced for construct. So this will loop over the elements of that particular array, and we can print out, let's say, the values. One of the problems that we have is we would like to refer specifically to one of the elements. We would like to know the index associated with each one of the elements of this array. So let's define an integer up here, and we can set it to 0 and increment that index each time we perform one iteration of this loop. So we can increment it this way, and then we can write, let's say, before mutation a, and then plus I plus parentheses equals the value of the associated element, which is going to be b in this case. So let's run this just to make sure that this prints out correctly all the elements of our array, and it does. Okay, so once we've done this, then we are going to call mutate array, which is again is a class method. and it's here, and we just need to feed our array, which is A. And now we can repeat this loop for printing all the elements of A, and this is after mutation. We need to be careful to reset only to 0 here, and we can run this. Okay, so as you can see now the effect of our function, of our method, sorry, was to mutate the third element of the array to 8. And the reason why it's happening is that when we are passing an object here, in practice what is getting passed is a reference to that object, which is, and that reference is copied into a local copy of the reference, but the reference still points to the right object, to the same object in memory, and therefore if we access any of the elements or any of the fields of that object, in this case any of the elements of the array, and set it to a number, the changes will be propagated to the caller. And so this is what I wanted to discuss pretty much in terms of the methods. Now let's talk about classes and instantiation of classes, or in other terms, our O1 unit. So in order to do so, what I'm going to do is to create a new package that I'm going to call O1. And as usual, we need a class that contains a main so that we can test all our ideas in terms of classes. So let's do that. And let's call this class objects. And this is where we are going to test other classes that we are going to create. And in terms of the class that we would like to create, let's create a class that represents a person. So I'm going to create a new class, and I'm going to call it person. That's our first class. So the first thing here that we would like to, that is quite important to notice, is that as per the class creation rules, we have a keyword associated with the access rights to that class. So this is a public class. It will be accessible outside of the scope of this class itself. So it will be accessible, for example, from this other object class. And then another important keyword that we might want to use is if that class is a subclass of a given superclass, it extends that superclass. And we also have discussed that all classes are subclasses of the object class. So I can safely say that person extends object because it is a subclass of object. And in fact, this happens automatically. And this is because all classes are automatically subclasses of the object 1. Then I would like to define some fields. Let's say that we have a private field, so that's not going to be accessible outside of this class, that I can call age, and another private field, which is an instance field, right? I'm not using static here, which is the name of that, associated with the name of that person. So since these are private fields, I cannot access, if I was to instantiate person, so to create an object of the person kind in our main function here, I wouldn't be able to access these fields. The way you access or actually obtain values which are associated with private fields is through using a public method. These methods are typically called getters because they get the value of one of the fields and then they return a copy of that value. And what is great in IntelliJ is that there are automatic ways for generating the code for getters. So if you right-click here, you can generate, there is this option of generating code, and there are a bunch of different functionalities that you can generate in your class. One of these functionalities is associated with getters. And here you can select which one of the variables the getter should return, which one of the the value of which variable the getter should return. For example, if it is age, as you can see here, it will generate a public method that will return a copy of age so that we can access it in our main function. And this is extremely powerful. We can also generate at this stage, therefore, another getter, which is going to allow us to return the name of that person. And so we click on OK. And as you can see, we have now two nice functions, with two nice instance methods, which will return values associated with these private fields. Now, we can test this. So if we go in our objects class, we want to create, of course, a new instance of this person. So create instance of person class. And we have seen that the way to do this is to do a declaration plus instantiation by using the name of the class, the name of the variable associated with the class, so let's call them person1, the new keyword or operator, and then we need to call the constructor. We haven't really defined the constructor, right? So somehow, and I will tell you what is happening here, the compiler must be able to have a default constructor when we do not provide one. And to see what is going on here, let's try to print out our person, as we've done in other cases. So let's do person1, and let's see what happens. Okay, so as you can see here, we get the usual kind of printout where there is the name of the packages and of the class which we are trying to print, as well as this hash which is associated with the memory location of that particular instance of the person class. So how does this happen? Well, the reason is that if you do not define a constructor, a default constructor will be synthesized. More specifically, the constructor of the parent class will be used as a constructor for the child. And so as we have also written it here explicitly, we have the person class extends the object class, and therefore a constructor has been created by using the constructor of the object class. So somehow the constructor of the object class is set to yield this particular behavior. Now, I was looking at my notes just to check what I wanted to tell you next. So one thing that I haven't clarified so far is that when we are using system out, I mentioned a few times already, system out must be calling a specific method so that it can convert this object into a string representation, or some of the fields associated with that object into a string representation. And so how this is happening? Well, in reality, this is happening by calling a method called toString. And so in this case, by default, once again, the toString method, which is associated with the object class, is getting called when we are doing sout on the person object. And that is because the toString method, it's calling the toString method of the parent class, which is the object one. So if we want to have a better way of printing information associated with a given class, we must specialize, or so to say override, and you see why I say that, the toString method within the person class. So let's do that. So this toString method here, as you can see, IntelliJ is already saying if you're calling toString, I can actually generate that for you. And that is exactly what it has done here. Now, once I have generated this toString method, this is what will be called by sout to generate a string associated with that particular class. Now, we have two new keywords here. One is override and the other one is super. Let's talk about super first. What super means here, it's a keyword which is which indicates the superclass. So basically, this super stands for the superclass, which is the parent class in this case, which is object. So in this particular toString method, we are calling the toString method of the parent class, which is the object class, and returning that string. All override is doing is indicating that we are overriding the default behavior of the toString class, of the toString method in the person class by using this definition. However, this would not result in a change, right? So if we run again our object main, we will get exactly the same result. And why we will get the same result? Because yes, we are overriding it, but we are overriding it with the same behavior as before, because we are calling the toString method of the object class. So what we want to do here in order to improve this behavior is to have a way to fill our fields first, right? Because if imagine that we want to print out a more informative set of strings associated with the person class, ideally what you want to do, typically what you want to do is to print out the values associated with each one of the field variables, for example using getAge and getName. But at the moment when we are creating the person class, we are not setting default values for these fields, or we are not setting meaningful values for these fields. So in order to do so, we need to provide an additional constructor. A constructor that, when called, will initialize the person object with values that will be used to initialize age and name. So let's do that. Let's write our first constructor. As discussed during the lecture, a constructor can be thought of as a special method where you have the permission rights associated with these keywords, the access rights associated with public, private, and so on. Doesn't make much sense to do unless in particular circumstances of having private constructors. But this will have, in order to be a constructor, needs to have the same name as the class. And now we can have a so-called parameterized constructor. This is where in your constructor you are providing parameters, and these parameters are going to be a string called the name, so we can initialize one of our variables, one of our fields, and int age, so we can initialize our second field. And now how do we distinguish between the variable in age, which is the instance variable of this object, and the variable associated with the primitive data type that we are passing as an argument to this constructor? As discussed during the lecture, the way to do this is to use this keyword. So we can use this name and set it to name. So this name indicates our instance of this field name, which is specific to our object, while the right-hand side indicates the variable name that we are passing to our constructor. And we can do the same with age. Of course, we don't have to return anything. This is a constructor. And we can see already that there is one related problem being flagged here. And the issue is actually in object, right? Because we are now trying to call this constructor. So now that we have defined the constructor, the default constructor, which in this case doesn't take any argument, won't work anymore. So that will be eliminated. So if the moment we actually define a constructor in our class, the default constructor, it's not defined anymore. So we need to change the way we're calling the constructor because this is now at the moment not defined. And if we want to do so, we need to provide two arguments here. One is going to be the name of the person and the other the age. So let's say this is Freddy and the age is 23. And we can create another person if we want. Person 2, and let's call it Deborah, who is 32. Okay, so now everything works in terms of the creation of those objects. We can run this. We still have the problem here, right? Because we haven't redefined our toString method. So let's go back to, now that we have our nice constructor, let's go back and redefine this toString method. And once again, IntelliJ is great in helping us. We can regenerate, now that we have a nice constructor, a better version of the toString method by going on generate. And as you can see here, it's asking us which ones of the fields associated with this object would you like me to integrate in the string printout of this object. So let's say both of them, and now we are overriding the default behavior of toString, which will be the one of, again, the object class, by specializing it for the person class, which is going to give us this printout. So let's see what this does. We can S out both of them, and let's run this code. And as you can see now, this is much nicer than before. And we have now a nice printout of the age and name fields associated with each one of the instances of that particular class person. Of course, we can also make this better. So let's say that, for example, we would like to have a printout which is more meaningful. What we could do is to change the toString method to start with a name. So name here plus is a person, meaning it belongs to the person class, and is, we can put the age here, plus another string, years old. And we can remove the rest of it and conclude this statement, and then we can run this. And as you can see now, this is a much nicer way of doing that. The other thing that I haven't, there are still a couple of things I would like to show. One is, naturally now we can, that we have initialized a way to initialize through the constructor name and age. We can actually call these instance methods, and the way we call them is directly from the instance, not from by using the name of the class, but the name of the instance, and we could call getAge, right? And so we can once again we could do s out here, and then if we use the person name as well by using get name, this will return already by default a string, and then we could say is, and then add the age, and run this. Okay, that's great. So as you can see, this now everything is working out. Last thing that we want to do, for example, might be to be able to change the one of these private fields within the class. And to do that, we have to use methods, a public method, of course, which is typically called a setter. And once again, IntelliJ provides the functionality for generating that method. So let's say we want to be able to change the age of a given person. And so as you can see here, this is going to be a void method in which we pass as an argument an integer called age, and it's going to set the instance value, the value for the instance field of our object to that particular age that we passed as an argument. So let's try this in our main here. So let's say person1, somehow we are setting their age now to something else. It was 23, so maybe it was just their birthday, and now we're going to set it to 24. Then we can call again this s out to check and show that the value has changed. Okay, so that gives you a way to change a private instance field of your class. And this is all I wanted to discuss about basic object-oriented programming, just because, and I wanted you to go with me through these examples, because now assignment 1 is out, and I believe that this can be quite helpful for you in starting up your work on assignment 1.